Okay, let's get started. Prerequisites for this is a DNS name provider. For this I'm using name.com, and a VPS cloud service I use UpCloud. Account setups for these are pretty standard and straightforward. If you'd like to see the process on the account setup, I have a link to a tutorial on how to do all these prerequisite setups. Once you have your account set up, the installation process is like this. We're going to set up a server first. We're going to choose San Jose, California. The general purpose plan at €7 a month. Debian 11 operating system. Login method is going to be using SSH keys that we generate on our desktop. No initialization script. The name of the server, blackpoint.com. If it's a mail server, we put mail.blackpoint.com. Then just hit deploy. And that will take a couple minutes to get started. But what we can do now is copy this IP address for that server, and we can put this in the answer field for blackpoint.com, a record. You can either use the @ symbol or blank. First I'll use an @ symbol so you can see, and that creates the host is at the default host. Alternatively, on here you can just put nothing, just the IP in the answer field, and it will do the same thing. The next record we want to put in here is www. For our SSL certificate, it's required to have the domain name and then www subdomain, and then we're going to want to put mail. These are all A records. So we've got these 3 A records, and the next record we're going to put in is going to be an MX record. The answer is going to be pointing to the email server. Blackpoint.com points to mail.blackpoint.com. These are the 4 records that we're going to start with. Now on here, we want to go to this tab network, and we're going to put in a PTR record, which is also known as the reverse DNS name. If you get an error report, they usually refer to the reverse DNS name as a PTR record. So we have an IPv6 address here, and then our IP address here. We want both of these to have the reverse DNS name that's identical to our server name. Both of these will be the same. This loop right here is required to run an email server. Now let's log into this server. What I like to do is go ahead and copy the IP address again, and in my daily record, when I'm running a test like this, I'll write in the login information for that test server, SSH root at IP address. Our primary user is going to be Dylan. The best practice in running a server is not to run the server as root. In the initialization script, we set up a pseudo user. For these servers, I use admin for the email name, for the email account. And the way this works is, when the email server is installed, you set up a user that doesn't have root privileges, so that that user is isolated in what it can do. Because we're using a plain text password, we don't want somebody to be able to brute force attack that, get into this account, and then be able to modify the server. So this account right here will not have any root privileges. This account is what you can use to log in to the server using Google as a client. Okay, so here we go. We're going to log in as root. When you first log in, it's going to warn you that this is an unknown server, that it's new, and it's going to ask you if you want to trust the fingerprint of the server. So we're going to put in yes, and there is no password. It's going to check beforehand whether or not you have a valid SSH key for that server. If you don't, it's automatically going to kick you. There is no place to put in a password. This is why it's secure, because you can't brute force attack these. You have to physically have that key, otherwise it will automatically boot you. This key is locked on my computer by a password. So that's what the passphrase is. It unlocks the key on your computer. So this isn't doing anything on the server. It's just asking you to unlock your key so that you can send it to the server to decrypt and authenticate. So now that we're en route, we're logged into the server, we're ready to install and run the script. This is my GitHub account. Springb0ard should be pinned on the front. We're going to go into the folder, into the program files, and the one we want is get email root. So open this, and what we're going to do is we're going to copy and paste this into the server. But in order to do that, we need to create the file. So we're going to create this file, copy and paste this. Sometimes when you copy and paste, you'll get some extra characters at the end. You want to make sure that when you copy and paste that it's identical and that there are no extra characters, otherwise it won't work. So now that we have a file open, that's basically what this is doing. Nano is the editor. We're creating this file with the .sh. I'm going to copy this whole bit here. All you have to do is, if you're using VS Code, is to right click and it just automatically pastes it in there. Otherwise you can do Control-C. Now again, best practice, always make sure that you don't have extra characters at the end. And once that's in there, you can do Control O, and that writes out the file. Control X will exit right out of it. So now that we have this file, we can use cat to verify it if you want. Totally unnecessary, but maybe it'll give you an idea of how to use these different commands. So cat just prints to the terminal everything that's contained within the file. So we have this, and in this we want to make this script executable, so we're going to copy this, and that is a change. It modifies this into an executable so that you can run the script. And to run the script, it's a period / then the file name. This is installing some basic software that we're going to need. The first thing that it does is run a system update, where it updates and upgrades the Debian operating system to the latest security tools and standards. Now we're downloading Snap, which is a repository that has software. Snap allows us to download BTOP. Now we're going to create a user with sudo privileges. So you just type in the name that you want to use, and this is going to be Dylan. For generating SSL certificate, you need to provide a administrative email account. It can be whatever, a Gmail account, doesn't matter. Now we enter the domain name that we're going to use. We don't add www or mail subdomains. We just enter the domain name. In this case, blackpoint.com. Now this creates the username for your virtual inbound email address. So this is your email name. So your email user is going to be admin. This is where you're going to go ahead and type in your sudo user password. Now what this is doing is creating a firewall, and it only allows certain applications through that firewall. So by changing the firewall, we're initiating the firewall now, and if it's not configured correctly, you can permanently kick yourself out of the server. But this just warns you to make sure that you've configured the server correctly and that you've opened the correct port. This right here, it's already been allowed. We're going to type yes to proceed. Now it's installing Git. Git is the core system we use to manage updates for Springboard. In addition to that, it provides a lot of different services, and you can back up configuration files to GitHub. As Springboard evolves, you'll be able to import open source code bases directly into the server. This will allow for fast deployments. By allowing you to clone GitHub repositories, it makes the server very extensible. Right at the end, it's going to switch you from your root user to your new administrative user. Now we can type the deploy command to continue with the installation. Now this opens up all of the required mail ports, port 25, 554, 955, and the www ports, which is 80 and 443. So this password is for your email user that you can log into externally. This is what's going to show up when you email somebody as the return name. Verify the information is correct, or you can press no to start over. Now it's setting up Postfix and automatically configuring Postfix for you. Before we proceed with SSL certificate generation, it just prompts you to make sure that you've put in these records. Now where you see @ it's going to be, in this case, blackpoint.com. You can either leave those records blank when you're typing them in like I showed you, or you can put the @ symbol and the host will automatically generate. So these subdomains, this will be www.blackpoint.com, mail.blackpoint.com, blackpoint.com, blackpoint.com. Okay, now go ahead and verify by pressing enter that you've entered the records and that you're ready for the generation of the certificate. It's going to prompt you for that email address again that you use as your administrative email. Agree to the terms and conditions of Let's Encrypt, also known as Certbot. We're going to type yes. This will ask you if you want to receive emails from the Electronic Frontier Foundation. I have agreed to this multiple times and I don't need any extra. So I'm going to click no. I'm going to type no. Now it's requesting the certificate. When it says cleaning up challenges, that's usually a good sign. Now Dovecot is installing and configuring itself. What it's doing now, this demonstration creates a landing page and then creates the SSL certificates, that landing page as well. It's installing an Apache web server and then creating an Apache config file, and then this certificate's generated using that Apache config file. Now that the script is completed, it's automatically created some DKIM keys for you. So omit the -e, that's a bug I have to work out. It's adding this. Copy everything after that from this parentheses to the default, the D in the default. Go into your name.com account. This is a text record. Host is @ answer is the DKIM keys. Okay, so that the text record, when you use @ or just leave it blank, will just default to blackpoint.com. That points to this DKIM record. The following text record is going to be the same.